This video provides an overview of multiple comparison procedures. If we reject the null hypothesis, we use multiple comparison procedures to see which specific means differ. There are many multiple comparison methods available. It is easy to find yourself overwhelmed by the sheer number. To help with this, I'm going to narrow the focus to just a few tests that have been shown to have good statistical qualities and procedures that use pairwise mean comparisons, since these are the most widely used. When determining the appropriate procedure, it's important to take into account whether all the ANOVA assumptions have been met, and whether the sample size is the same for each group. We'll look at the Tukey HSD, or honestly significant difference test. We'll also look at the Gabriel and Hochberg procedures and the Games-Howell test. If all the ANOVA assumptions have been met, and the sample sizes are equal, the Tukey HSD should be used. If the assumptions are all met but the sample sizes are slightly different, the Gabriel post-hoc test should be used. And if they are very different, the Hochberg test should be used. If the equal variance assumption is violated, we do an alternative ANOVA test that is robust to this violation, and if the ANOVA results are significant, we use the Games-Howell post-hoc test. We're focusing on the post-hoc tests, below this line. Most of the examples we will do in class are a straight shot down to Tukey. The lab data files have unequal ends, so you will be looking at Gabriel or Hochberg. In experimental research, the sample sizes are usually equal or very similar, but unequal ends show up a lot in observational research. Here's how to use the flow diagram. Before we do the ANOVA, we check the equal variance assumption using the Levene test. If this assumption is satisfied, we move down to the ANOVA, then to one of the three post-hoc tests below. Which test we use depends on whether the sample sizes are the same, slightly different, or very different. Tukey if the ends are the same, Gabriel if slightly different, and Hochberg if the sample sizes are very different. If the equal variance assumption is not met, we do the Brown-Forsyth test, which is a robust version of ANOVA. If the data are extremely non-normal, as in ordinal data, the Kruskal-Wallis nonparametric test would be used. You choose the appropriate post-hoc test from the ANOVA procedure's multiple comparisons window. Tukey HSD is listed simply as Tukey. You'll also see the Gabriel and Hochberg procedures listed here. When the equal variance assumption is not met, we select the Brown-Forsyth ANOVA procedure from the ANOVA options menu, followed by the Games-Howell post-hoc test. To summarize, the particular ANOVA post-hoc test depends on whether the assumptions have been met and whether the sample sizes are the same. If all the assumptions for the analysis of variance are met and the sample sizes are equal, use the Tukey HSD procedure. If the assumptions are met and the sample sizes are just a little different, use Gabriel. And if they are very different, use Hochberg. If the equal variance assumption has not been met, use a robust ANOVA such as Brown-Forsyth and the Games-Howell post-hoc test. Finally, if the normality assumption has not been met, as when the data are ordinal, use the Kruskal-Wallis test, the nonparametric equivalent of analysis of variance.